Okay, so let's move on. So yesterday we have discussed about minimum path sum, right? So we have seen the brute force approach. Let's move on to memorization and tabulation. Let's see how it works. Funda is very simple, right? How you should do is, for example, while practicing, this is how you should do. So while I'm doing, while I'm explaining, I'm making a diagram little clumsy, right? If you closely see, this was our diagram we discussed. It was very clumsy, right? So then whenever you are practicing, as you already know the concept, for example, this is how it is, right? We have 131, 151, 421. So this is 012, 012. Yeah. Okay. So this is our last one. I think we went for other example, right? So let me go for it. What is the one? 321121. Okay. So 321121. So always come up with the simple input so that the recursion tree will go too high, will not go too high, so that it will help you to come up with the solution at the earliest. So yeah, so this is the problem we discussed, right? It's the same thing. So we start from 0 0. Either you can take down or right. If you take down, it becomes 1 0. This is down, this is right. 0 1. Similarly, here also you can take down or right. Here also you can take down or right. So 2 1 means this is 2 1, right? So this is the 2 1 cell. So row 2, column 1. So you reach the end. 3 0 means you already reached end of the grid so that you can't move further. So similarly, this is also 2 1 and 1 2. So if you closely see, this is column 1. So 2 means you are reaching out of the grid, so you can ignore it. Similarly, this becomes 1 1 and 0 2 and 2 1 and 1 2. So now this is the tree, right? So simply I made it for explanation sake I made it something like this, right? But to make concept clear, make your diagram very clean. So this is how it is. Now you come up with the edge cases. You already know that. So when the column is exceeding, so it is column, right? So column is exceeding 2, and this is also invalid, and this is also invalid. And do we have any other place? Yeah, this is also invalid. Now we want to find out minimum path, right? So we want to find out the minimum path, and we understood that what is the minimum path we understood. So this one, right? This is the minimum path. As per the earlier discussion, so we have understood that this is our minimum path. So let me highlight it here. So we want to find out a minimum path so that what we should do, whenever you reach a base case, you return the same value so that what it will return definitely this is how it should be. This is how you should write. So I start from generally this is our minimum path, right? So this is our minimum path. So we need to return 6. So there are other possibilities also. We do have other possibilities. For example, if I go this way, which is costing 7. If I go this way, this is also costing 7, the sum of all these cells. But this way is costing only 6. So that's why we need to return this minimum path. So this we already discussed yesterday. Hope you are following me. So how you should do is from the current cell you should start, right? So current cell value is 3. So take 3 plus find minimum of these two. So what is the minimum value you get to down or right? So find min of these two. So obviously we go first down. So let's go down. So at 1 0. So 1 0 means this one. At 1 0 you have value 1 plus find minimum of these two. So let's go for 2 0. So 2 0 value 2 plus find minimum of the minimum of these two. We need to find minimum of these two, but we reach the edge case, right? So 30 means it is out of the bound. We need to find minimum, right? That's why you need to return max here. So that this is going to invalid max value. So integer dot max, whatever it is, integer dot max you return from here. And this 2 1, so 2 1 you are reaching edge case, right? So you can return 1. So max comma 2 1, the minimum of these two. So you need to find out min of these two values, right? So we need to find out min of these two values. Minimum of max comma 1, so which is 1. So that 2 plus 1, so which is going to be 3. So it means this will return 3. This will return 3 to the caller. Now find out other end. So you see that from 10 if you take down you went to 20, and to 20 you find out the minimum of optimistic result. If you closely see from 20 you can only take right, the sum is 3, so you already got, that's a possibility you get. Now let's move on to 1 1. So this is 1 1. So from 1 1 either you can take down or you can take right. So if you take right, again it is out of the bound. So obviously what you do, you will return the max. So from 1 1, so go to 1 1. What is the value? So you have 1 plus find minimum of remaining direction. So from 2 1 you will return 1. So the min of these two will be 1. So obviously you will return 2 here. So if you closely see from 1 1, I can take the sum. I have only one direction. I cannot take right because it is max. The down it is 1, so that you will get 1 here. So 1 plus 1, which becomes 2. Now you see that from 1 0 I take down, I got value 3. I take right, I got value 2. So we need to find minimum of these two. So the minimum of these two will be what? 2. So that you will just take that 2. Fine. So take that 2. Then you got the answer as 3. Okay, nice. Now if you closely see, that's what happening, right? So if you closely see from, let's go to 1 0. I'm at 1 0, right? So this is 1 0. So one way is I can go, this is 1 0, right? So I can go, yeah, I can go this direction. So which is 3, and I can go this direction. Okay, just a minute. Is there any mistake, buddy? I'm at 1 1. Okay, 1 1 is fine. So this is 1 0. Yes, 1 0. At 1 0. Yeah, yeah. So if you closely see 1 0, so you have two possibilities, right? If I go, I'm at 1 0 here. If I go this direction, I'll get value 3. If I go this direction, I get value 4. So that I got optimistic result. So from 1 0, I went this direction. So that obviously I got value 3. So it means from 0 0, if you take down, you go to 1 0, you got the optimistic value 3. Now let's go right. Okay, so from 0 0, I'll go right. So obviously I'll go to 0 1. So that the 0 1 value will become 2 plus find out the minimum of other two. So definitely if you go down, you'll get 1 1. So 1 1 value is 1. 1 plus find minimum of these two. This is 1 and this is max. So obviously it will return 1. So this is going to be 2. And this is 0 2 means obviously it is max. So the minimum of these two is 2. So that obviously you will get 4 here. So that you need to find out, if you closely see from 0 0, if I take down and right and down, so I got, from 0 0, if I take down this, I'll get 1 0. So from 1 0 I got the optimistic result as 3. From 0 0 I take right, so from here I go down, I got the optimistic result as 4. So the minimum of these two we need to consider, so obviously which is 3. So take that 3. So finally our answer will be 6. So don't make your diagram clumsy, and make it more cleaner so that you can come up with the code. Okay, so that's what we written here, right? So what are we doing? So we understand the base case. We understand the base case. The base cases are, what are the base cases? So one is whenever your row is equal to m or column is equal to n, and you return max. Okay, so that is one base. Another base case is what? One more base case, whenever your row becomes m minus 1 and column becomes n minus 1, then you will just return that grid of this one, last column, or row comma column. So this is done. So these are the two base cases. And what is the other case? So you will consider the current cell, then you will go down and you will go left, sorry, right, and you will find out the minimum out of it. So that's what we did here. If you closely see, so whenever you are reaching out of the bound, you return max value. Whenever you are reaching last cell, you return that grid value. And again, you consider the down path and right path. So down path means row plus one, right path means column plus one. So once you find out down path and right path, so the minimum value you are adding to the current cell and you are just getting it. So this is a brute force approach we were explored yesterday. And the time complexity, what is it? 2 power m plus n, right? So this is 2 power m plus 1 and space complexity also m plus n. So this we discussed earlier. So now let's convert this into memoization, right? What happening? So let's convert this into memoization. So how do you convert into memoization, buddy? So first we need to understand what are the duplicate subproblems here, right? If you closely see, if you closely see this subproblem 1 1 you solved here. Again you try to solve here, right? So you are trying to, you solved already here, you are trying to solve here. So don't repeat the same sub problem again and again. So once it is solved, you don't need to resolve it again. So how do you identify the, now how do you identify the duplicate sub problem here? Tell me, how do you identify the duplicate sub problem here? How do you identify these two sub problems are duplicate? Okay, you are speaking but I can't hear you. Can you hear me? What's happening? I can't hear. Just a minute, I can't hear your voice. Can you speak now? Okay, somehow I am not able to hear you. This is also fine. Okay, so let's make output as, can you speak now? Yeah, yeah, now I can hear you, I guess. Yeah, you can speak now. Yeah, but how many indexes we have here? So we need to identify duplicates of problems, right? How many indexes we have? Oh, sorry. So how many indexes we have, buddy? Yeah, so there are two indexes, right? So one is representing row, another is representing column, correct? Correct. So it means this is 1 1. 1 1 means one is representing row, one is representing column. So you are having two indexes. Definitely you need to come up with a data structure which is representing the complete cells of a grid. Okay, the complete cells of a grid. So definitely what should I do? I should come up with uh, a DP array. It's a two-dimensional array. So till now we went with single dimensional array because there we have only one index. But in this case we are having two indexes. One is representing row, one is representing column. So that I am going with two-dimensional array DP, and this is my two-dimensional array of length same size of grid by, right? So what is the maximum row value, maximum column value, buddy? Maximum row cell number, maximum column cell number, which is equivalent to given grid size, right? Yes or no? Yes or no, please? Right, so which is equivalent to given grid size. So that definitely you should come up with a DP which is of size m, n. So m is the grid row length, n is the grid column length. So you just come up with it. That's it. So once you solve it, you don't solve it again. So I will just change this code. I'll just change this code. So please take a look. So what I'm trying to do, I am going to consider integer. I'll take it as a wrapper type so that I don't need to fill with default values. By default, it will have null. So what I'll do, row is your grid dot length, column is your grid of 0 dot length. You can consider it as yum yan, but okay, so we already took it here, right? So let me do that. So this is yum, this is yan. Okay, so let's consider your DP array. Row is of same size, column is also is of same size. Now you pass the DP. Okay, so let me pass the DP here. What is our job? First, we will consider the base cases. If it is, then we will check whether my current DP of given row and given column is not equal to null. It means which is already solved. So just return that DP of row and column. Otherwise, what you do, you will just make DP of whatever result you get. So store that into DP of row column, then finally return the DP of row column. And whenever you are calling a method, just call DP, call DP. That's it. So to convert your recursive solution to the memoization, right? The most importantly, you just need to understand the state of a problem. That's it. Once you understand the state of the problem, and you can understand with the diagram, you can understand that what are the problems which are repeating. Based on that, you can define the state of a problem. Once you define the state of the problem, then everything is in your hand. That's it. So what is the time complexity here? What is the time complexity? Yes. What is happening? No suitable method found. Okay. I didn't declare DP here. Yeah. So So this is going to be order of m cross n, right? So m by n. So what do you under how it becomes m by n, buddy? So earlier uh, earlier we see that the time complexity is 2 to the power m plus n, but now the time complexity is to order of m by n, right? So for memoization. Oh. So earlier for brute force the time complexity is 2 to the power m plus n, but for this the time complexity becomes order of m by n. Why? Because you always think that how many subproblems at max I can solve, right? So at max you can solve the subproblems as m by n, and which are not repeated. So if you closely see, this is what happening, right? In this case, every in this case, if you closely see, this is row, this is column. So I try to solve. Once I solve this subproblem, again I don't solve it again. So at max, I can solve m by n subproblems so that the time complexity which is going to take m by n. So what is the space complexity now? So we need to talk about with respect to stack frames plus with respect to DP array. So what is the space complexity now? How many stack frames it takes for this? Mn or m plus n? For example, you have 3 by 4. So how it goes? 0, 0. First you go down 1, 0, 2, 0, 3, 0. Okay, then what you do? So 3, 1, 3, 2, 3, 3, and 3, 4. Right? So this is the maximum direction you could see, right? So first you completely down, then you completely take right. Correct? So yeah, so definitely it is going to be order of m plus n. Correct? So which is going to be order of m plus n, so it's not mn. Okay. So plus the DP array is going to be order of mn. Is this clear? So clear, buddy. Okay, nice. Now let's move on. How do you convert this into tabulation, right? What I said, whenever you are going with tabulation, whenever you are going with the tabulation, so what are the points to consider? Okay, so don't rem never ever try to come up with tabulation with your own thinking, buddy. So it is, if you do that, it's like by hearting the code. So never ever come to tabulation with your own thinking. Blindly go to memoization solution. So tabulation. So go to memoization. So you need to go, just go to there, and the tabulation is reverse of memoization, right? So memoization is a top down approach, right? So this is top down. So what we did, so we start from 0 0, and we went to n minus m minus 1 comma n minus 1. So whenever we went down, so here don't think that top down means it will start from n, go to 0. It's not like that. It's about how you solve the problem, that's it. So this, you start from 0 0 index. That's what we did, right? So initially we passed 0 0 index. Then whenever it is reaching m minus 1 and n minus 1, then we are trying to obtain the results, right? Similarly, so it means we went on to m minus 1 comma n minus 1. So then we will try to solve the problem, right? So tabulation means it's a bottom up. Bottom up. So bottom up means you will start from m minus 1 comma n minus 1, then you will move on to 0 0. So this is bottom up. Okay. So now the good part is when it comes to bottom up, when it comes to top down, right? So you don't have to maintain the order of the elements. You can solve the problem in any order. So the recursive solution, you don't have to know on which order my code has to execute. So it can take care of the recursive calls. For example, if you closely see how it works, first it will go here, then it go here, then it go here, then it go here, finds the results. Once it gets the result, then it will go here, then it will go here, here, and finds the result. Once it will find the result of this, then we get the answer to this. Once this is done, then it will take other direction. So there is no order of execution. Of course, there is a sequence of flow, but you don't have to know that. But when it comes to bottom up, you must and should know order of the solution. And for the bottom up, you must and should know base of problem result. Okay, so base up problem results. So how do you get this base up problem results? Don't apply any brain. So in in your code, right? So in your code, what is the base result you retain? That is going to be the main result for your. That is going to be the first result for your. That is going to be first result for your tabulation approach. It means here also you are going with same array. Okay, here also you are going with same array. So DP array of size m and n, and what you should do, you just first replace m minus 1 comma n minus 1, which is equal whatever value you are replacing here. So grid of row column, right? So row equal to m minus 1 and column equal to m minus 1, so you can simply replace that, right? So you can simply replace that. I can say that dp of m minus 1 n minus 1 equal grid of m minus 1 comma n minus 1. It means you found a first result. You found a first result. For example, if you see this is your grid, if you see this is your grid, so this value you have. Now you need to, either you can reach from here or you can reach from here. Then from when you come here, either you can reach from here, either you can reach from here. Then this you can derive from you already solved that through memoization. So I don't explain the table. If I explain the table and you will buy hot on the code, so better what I'll do, I don't explain the table how it feels. First, let me convert this into tabulation. Then we will fill the table. So you will understood. So till here it is fine. Till here it is fine. Then what you should do is whatever base result you are getting, right? So this is our base result. dp of m minus 1 comma n minus 1. So this is your brace result. So which is equal grid of m minus 1 comma n minus 1. Okay. So first you filled it. So this is we took it from the memoization only. Okay. So this we took it from memoization. If you closely see, Memoization is a top-down approach. It is starting from 0, 0 to m minus 1 and n minus 1, but ours is bottom up. So it will start from m minus 1 to n minus 1, reach to 0 to 0, right? So this is ours is bottom up. So now let's move on. How do we do that? So simple. So simple. If you closely see, so what you do, it's a bottom up, right? So for integer row equal to m minus 1, row greater than or equal to 0, row plus plus. So for integer column equal to n minus 1, column, sorry, it's minus minus. So column greater than or equal 0, column minus minus. Okay, nice. So now till here it is clear, nobody? Everyone, please. Till here it is clear, right? So it's clear. Now one thing, so whenever you do this, first you write the base case. So when row equal to m minus 1 and column equal to n minus 1, so which you already solved, n minus 1, don't do anything. It's a edge, you cannot move down, you cannot move right, so that just continue. Generally here tend to get confused, so which is this is you just write it. Now what you do is copy this code, copy this code, paste it here, paste it here. Now let's see here, closely observe, let's see here, closely observe. For example, if I am at, so I'm going in reverse direction now, buddy. I'm going in reverse direction. So you see, this is dp of row plus one and column, right? Earlier we went into top down so that we don't know the solution of row plus one comma column. But in this case we are going bottom up, right? So it means when you are at 2, you already solved third problem. So the next problem you already solved because you are going in bottom up, right? Are you able to follow me? For example, you are at 1 1. So when you are at, when row equal to 1 and column equal to 1, by then you already solved 2 1 problem and you already solved 2 0 problem. Because why it is, because first you start from row 0, right? Row 2, right? So if you closely see, row starts from, how it works, hope you are following me. So first row starts from 2, then it will solve for 0 comma 1, so column 0 comma 1. So it means what it does, it will solve the problem of 2 2 0, and it will also solve the problem of 2 1, right? Now when you are at, when you are at row 1, so row 1, so you need to solve for 0 comma 1. It means row 1 means 1 comma 0 and 1 comma 1, right? So now you see, so from 1 0 1 0, if you take right, so from 1 0, if you take right, for example, if you take right, what will happen, it becomes 1 comma 1. And from 1 0, if you take down, if you take down, so it becomes it becomes 2 comma 0, right? So from 1 0, you can, if you take right, it becomes 1 comma 1. If you take down, so it becomes 2 comma 0. Is it correct? Okay, so write 1 comma 1, 2 1 2. Okay, so similarly from 1 1. So how do you solve it, buddy? Column also starting from n minus 1, right? So first you will solve 1 1. Don't get confused. So column also going in this direction, right? So 1 0. So first you solve 2 1, then you will solve 2 0. Here also column also going in this direction, right? So 1 0. So it's also starting from n minus 1. Okay, so don't get confused here. This is the first, next time I won't repeat it, so please carefully observe. First you will solve 1 1, right? So once to solve 1 1, so first you take right. So to take right, so definitely it is going to be 2 1. Then you take down, then you take down. So down will definitely take what? 2 2. So if you down will take 3 1. So 3 1 is the wrong case. If you closely see, when you are solving 1 1, you need 2 1. 2 1 is already solved in previous step or not, buddy? Yes or no? Yes or no? Do you get me, please? So 2 1 is already solved in previous step, right? So that's what the bottom up is talking about. For example, if you are at 1 0 and you take right 1 1 and you take down 2 0. So when you are at 1 0, 1 1 is already solved. 1 1 is already solved and 2 0 is already solved. So that's how the beat bottom up works. For example, if you see you are at 1 0, whenever you come to 1 0, if you take right, it is 1 1. If you take 2 0, it is down. So that 1 1 is already solved in previous step and 2 0 is already solved in previous step. So that's what I'm trying to say. So whenever you are going with bottom up, you already solved previous subproblem results. Okay, that's a conceptual understanding. Now let's not think about any concept. So what you do, whatever you have, it's a bottom up, right? So whatever you have, so just replace with dp. Okay, dp of row plus 1 and column. Okay, nice. This is simple. I'm just taking the same code. I'm just replacing it with dp. So this min path, earlier we didn't know the solution of it. That's why we explored it. Now we already know the solution of it. So when you are into current problem, whatever subsequent problems we are trying to solve, which are already been solved, which is present in the dp array, so just take that value from the dp array. That's it. Okay, now there is a check here. So what I will do, I'll just take 0 or initially here also we did the same, right? So initial values are integer dot max value because I need to avoid out of bounds. So what I'll do, so I'll check here if my row plus 1 is less than yum, then I will just make down path equal to dp of row plus 1. Similarly, this is my right path, right? So if my column plus 1 less than n, then I can take the right path, otherwise it will be same. So let me format it. Do you understand, buddy? Do you understand? This remains same, right? Again, dp of row column remains same, right? This principle remains same. Understood? Maithili, Ajay, Kalyan, I beg your thumbs up. Okay. Ajay, clear? Mhm. So one way is you can, if you closely see, if you understand this, right? First we start from row number 2, right? Then we start from, for row number 2, we start from column number n minus 1 to 0. It means for row number 2, this is how it goes, right? This is how it goes, right? So now, what are the sub problems? So what are the sub problems you derive for row number 2? So one is 2 1, one is 2 1, another is 2 0, correct? So one is 2 1, another is 2 0. So 2 1 means which is m minus 1 comma n minus 1, because we have m equal to n equal to 1. So that you already solved it. So you just take that result. So it means for 2 1 we have the result, whatever result we have. So with respect to our diagram, if you closely see, so with respect to our diagram, the 2 1 value is 1. Okay, so let's take value 1 here. Okay, so dp of 2 1 value is 1. Okay, now 2 0. So 2 0 you take right or you take down. So if you take right, it becomes 2 1, right? So let's go on. So for 2 0 you take right. So if you take right, it becomes 2 comma 1. Correct? Correct, nobody? So 2 1. So you see 2 1 is already solved, right? 2 1 is already solved or not? So it means to write So what you are doing, so right means column plus 1, right? If column plus 1 less than 1, we just take that value. So current row plus column plus 1. So it means 2 1 right means what? Current row is 2, column plus 1. So column plus 1 becomes 2 1, right? So you just take that value, so which is 1. Okay. So I took the right value as 1. And down. So if I take down, so for down, if you see, you are 2 0, right? So from 2 0 down means, so how it becomes? It becomes 3 0. So 3 0 means, if you closely see, my row plus 1 is not less than m, so that it will have max value. It will have max value. Okay, nice. So it will have max value. Now what are we trying to do? So we are trying to say replace dp of 20, dp of 20, which is equal to, what is the value present in dp of 20? So just go there. So dp of 20 value is 2, and 2 plus, and minimum of these two, so which is 1, so which is going to be 3. Now it means what we solved 2 1 and we solved 2 0. Both the sub problems already been solved. Now it means there are no possibilities to explore, because column is already reaching 0. Now you are again going back and row becomes 1. So this is second step. So row 1, again you repeat the same problem, 1 0. And now you see, for row 1, first you will go on to the right. First you will solve 1 1 problem. So you are trying to solve 1 1 problem. 1 1 means right becomes 2 1, down becomes 3 1, and 2 1, if you closely see, let me explain this again. So let me explain this again. So from 1 1, so I can take right and I can take down. Okay, so initially I have max values here. So if I take right, definitely I'll go to 1 comma 2. Okay, so 1 comma 2. So if you see, 1 comma 2 means 2 is out of the bounds, right? The number of columns we have is 1. So 2 is out of the bounds. So definitely the right is always giving max. Then down. So if you take down, it becomes 2 1. And dp of 2 1 you already solved it, right? So dp of 2 1 is already solved it. So you just take that value 1. Now, now dp of 1 1 equal, so what is the value present in dp of 1 1? So dp of 1 1 value is 1. Okay, nice. Take that value plus the min of these two, so which is 1, so which is going to be 2. It means you solved 1 1. Now let's solve 1 0. So I'm trying to solve 1 0, 1 0. So if you are trying to solve 1 0, so definitely you take right, and you take down. So if you take right, it becomes 1 1. So dp of 1 1 is already solved, right? So dp of 1 1 is already solved. So that just take that dp of 1. So that is 2. And down means definitely it is going to be 2 0. And dp of 2 0 is already present. If you closely see, somewhere we have already solved. So which is 3. So which is 3. Now dp of 1 1 becomes, what is the value presented? What is it? Sorry, it is 1 1 or 1 0? It is 1 0. We are trying to solve 1 0. So what is the value present in 1 0? So 1 0 you have value 1 plus minimum of down and right, so which is 2, so which is going to be 3. So that's how you derive it. So whenever you go further, so what I'm trying to say is, when you are solving current, if you closely see, when you are solving, whenever you see row plus 1 less than m, it means dp of row plus 1 column is already been solved. You are doing bottom up approach, right? So in a bottom up approach, the order of elements will follow the sequence. So obviously you can blindly take that value, and similarly column plus 1, which is already solved, take that value, consider minimum of these two, add to the current grid, and which is going to be our current result. So this is the conceptual understanding. If you want to go with the memoization, just copy paste what I did. I just copy pasted, whenever there is a row plus 1 and column, I just replaced with dp. Whenever there is row plus 1 and column, I just replaced with dp. That's a that's a So you don't have to worry about conceptual understanding also. If you want to just convert that into memoization, uh, that's how it works. Clear, right? Ajay is like, if I don't say clear, he will not leave me. So this is Okay, somewhere I have. So finally, where the result will present, buddy? Tell me where the result will present in the first cell, right? So DP of 0, 0. Done. Okay, so yeah, so it's a 5% submission. You can refactor it. I don't waste the time here. You try refactoring it. It will work. Fine. So let's move on. Okay, let's move on. Okay, so to solve the next problem now, buddy, longest increasing path in a matrix, it's a beautiful problem on DP, but to do that, we need to know what is depth first search. Okay, I know depth first search is not something rocket science, it's a simple recursion code. Okay, so whatever recursive logic you did right, whatever recursive logic you did, so that is going to be the depth first search. First, let's understand the problem statement, then we will try to solve how it works. We'll try to solve it. So let's see. Don't worry about, don't keep depth first search concept in your brain. I will later explain about it. So what he's trying to say is you will be given a grid. So number of islands. So you will be given a grid. Okay, so this is your grid. So this is my grid. So let me take a grid uh, of m by n. So 0, 1, 2, 3. Let me take somewhat big. So it is also 0, 1, 2, 3, 4. Okay, so you have something like this. So this is a character, this is a grid, and you will have values 1 or 0. Okay, so I'll have value 1 here, 0 here, 0 here, 0 here, 0 here, 1 here, 0 here, 0 here, 1 here, 0, 0, 1, 0, 1, 0, 1, 1, 0, 1. Okay, so these are the values. One is representing the land, so one is representing land, and 0 is representing water. Okay, we need to find out how many islands are present in this grid, number of islands. So we need to find out how many islands present in this grid. Okay, and the path is either you can move horizontally or you can move vertically from any cell. So this is your cell. Assume that you can move vertically and you can move horizontally. So that's what he's trying to say. So island is surrounded by the water is formed by connecting adjacent islands vertically or horizontally. So if you are here, you can move vertically. So it means you can move top down or you can move left right. So let's understand how it works. So now you are here. So we need to find out simply number of how many number of islands we have. So from cell here, if I take right, so I have one more, one here. So I can make this as one island. Okay. Now let's move here. Here again, if I take right, I have one. So these two islands are connected. And if I go down, this is also connected. And if I go further down, let me take. Okay. So if I go further down, what happened? So this island also connected. If I go right, this island also connected. This if I go left, this island also connected. So if you closely see, all these islands are connected. So all these islands are connected. So this is one island. And if you closely see, this guy is separate. So he is not connected with any island. So this is one more island. So that the expected output is number of islands is 3. Do you understand the problem statement? Ajay, you clear? So now, yeah, so problem statement is clear, right? Now let's understand how do you identify that, right? So let's understand how do you understood that. So what I'll do, I'll take a simple input. I'll take a simple input, then we will walk through it. Let's go 3 by 3. 0 1 2 0 1 2. Okay, so I am here 1 0 0 1 0 0 1 1 1. So now can you tell me how many islands we have? Can you tell me how many highlands we have here? Right, so only two, right? So one is this one, and this is all connected, so this is going to be one. So how do you solve it, right? Simple, simple. So first of all, we can direct, we from a given cell we can take top, we can take down, we can take right, we can take left, right? So let's say cell, we are at middle cell. Okay, so let's say you are at middle cell. How do you note down the directions, which is more important? So assume that you are at a cell, the cell number is 1 comma 1. So you can take left, right, top, down. So right means what, buddy? Right means what? You are just moving on the same row, you are moving right, right? Yes or no, buddy? So what does it mean? So it's so you are on same row, you will just increment the column. So you are at same row, you just increment the column plus 1. So which is going to be 1 comma 2. Okay, nice. So left means what? Left means what? You are on same row, right? Again, you are on same row. You just decrement the column. Column minus 1. It becomes 1 comma 0. Correct, na? Clear, buddy. And down means what? What do you mean by down? So this is our down, right? So let me write. So it's down. Down means you are at same column, but you increment the row, right? So row plus 1 comma colon. So it means 2 comma 1. Up means what, buddy? What do you mean by up? You are going to the previous row, right? Yes or no? You are going to previous row or not? So row minus 1 comma colon. So which is going to be 0 comma 1. Understood the directions? Everyone understood the directions, buddy? Okay, done, man. So if you understood this, then the coding is dead easy. Now let's understand. I am going with the DFS logic. So let's see. First, I traverse the complete. First, I traverse the complete. So this is one. Let me erase this. Okay. So first first I will traverse this row. First I need to find out the number of islands, right? So there is no option. I need to traverse the complete grid. And whenever I find one, then I will find out what are the connecting islands to it so that I'll mark them as visited. Okay, that's it. So let's see. First what I do, I am at here, right? So I am at here. I am at here. So uh, I'm at this cell. First I'm at 00 cell. At 00 cell value is 1. Okay, nice. So as value is 1, then then I need to make a DFS call. Okay, so it's a depth first search. So it's like you will get to know that. So I'll make a recursive call, and which will pass the row, which will pass the column, which will also pass the grid. Then it will look for all the directions for this row grid. It will look for all the directions, and whenever it is valid, it will mark them as zero. So as I already visited, so let me see. I already visited this one, so that let me make it as zero, and I'll maintain one counter. So initially, counter is equal to one. Okay, with respect to zero zero cell, I found one, so that counter equal to one. After incrementing the counter, I am making a DFS call. Now I am at zero cell. So from zero cell, I'll take right. Okay, so if I take right, it becomes 0 comma 1. I take down, it become what? 1 comma 0. I take left, it becomes 0 comma minus 1. I take top, it becomes minus 1 comma 0. So if you closely see, my negative values are out of the context. Okay, so my negative values are out of the context, done. So I can ignore. At 0 1, if you see, if you take right, you get 0 1, which is already 0. So which is already 0. It is not island, so that I can ignore it. Similarly, at 1 0, which is also not island, so that I can ignore. It means from 0 0. If I start, I can get only one island, so that I mark that island as 0. So anyhow, the counter is 1 now. So I initiated DFS call from 00 cell because I found 1 at 00 cell, and I try to explore is there any connecting islands or not. If there are, I will mark them as 0. So which all together combinedly called as one island, right? So that's what I am trying to say. Then done. So with 00 done, I went to 01. It is already 0, 02, which is already 0, 03, 1, 1, 0, which is already 0. Now when I went to 1, 1, so this is very important. So when I went to 1, 1, now I found island. So that first increment the counter by 1, so counter becomes 2. Now connect all these islands, right? So connect all these islands. So now you are at 1, 1. So you are at 1, 1. Where can I write it? Let me take fresh. Closely understand how our DFS is working now, or simply a recursion. So DFS is nothing but a recursion. So I am at 1 1. Okay. So I am at 1 1. So what I did, I am at cell 1 1. Okay. At 1 1, I found there is island. So that first I increment the counter. Then I made a DFS call. Okay. So DFS for row 1, column 1 with the same grid. Right, now let's see. You are at 1 1. Okay, so first I add 1 1. So from 1 1, you can take left, you can take right. Sorry, 0 1. You can take, oh, sorry. So I can take left 1 0. I can take right 1 2. I can take down. What is it? 2 1 and 0 1. So let's move on. So it means from here you can take directions to the top, to the top, to the right, to the left, to the down. Okay, nice. Now let's understand here. When I go up 0 1, it is already 0, so that I can ignore. Let's go right. Okay, so if I go right, when I go right, which 1 2, which is also 0, so that I can ignore. When I go left, which is also 0, so that I don't need to explore, I can ignore it. When I go down at 2 1, we have value 1. At 2 1, we have value 1. So what I'll do, first I'll mark this as 0, then I will explore for 2 1. Because this is very important. So this is what the DFS is speaking about. So at 2 1, the value is 1, so that I mark it as 0. Then I will explore this direction. I will explore this direction. So when I explore, so what I'll do from this direction, when I explore, what I do, whenever you visit a cell, first you mark that as 0. Okay, otherwise you will revisit the cell again and again. So you visited this cell, so first you mark this as 0. Then when you go from 1 1, when you go top, right, left, all are 0. So when you go down, you got 1. So it means you got 1, 2 1. Now it's time for you to explore 2 1. So for 2 1, the righty becomes 2 2, the left becomes 2 0, the bottom becomes 3 1, the top becomes 1 comma 1. So let's move on. So from 2 1, if you go top, it is 1 1. So 1 1 you already explored, you marked it as 0 already. You marked it as 0. You can revisit the same cell again and again. By then you already marked this as 0, so that you don't need to explore further. So let's move on. Now from 2 1, I go right. Okay, if I go right, so this is what 2 2 I get. So first this is 1. So this is 1, so that I'll mark this as 0. Then again, we need to explore this part. So we will come to that. We need to again explore this part. So we need to explore this part. Okay. So we'll come to that. Now again, if you from 2 1, if you go left, again you found 1. So it means first you mark this 1 to 0. 2 0 is 1. So you mark to 1 to 0. Then again you try to explore this path. Then again, if you go down, it is becoming 3 1. It means you are reaching out of the bound, so that you can ignore it. Now let's move on. For 2 2. So 2 2, if you closely see, from 2 2, you can take left, right, down, top. So right is out of the context. Left, you already marked it as 0, so that there is no exploration. Down is out of the context. Up is already 0, so that there is no exploration. So that even if you explore, there is no DFS call is initiated. When the DFS call is initiated, when the value becomes 1. Okay. Similarly, when you explore 2 0, so you go down and left, top and right. All these were already marked as 0, so that this will end without further exploration. Do you understand it, or did I made you confused? Kalyan, understood, right? Done, man. If you understood what is the time complexity, or do you want me to explain again? Not required, right? Okay, so what is the time complexity? What is the time complexity? Now, do you understand the depth first search, buddy? Do you understand the depth first search? So, if you make, let me draw the diagram again. Uh, 100, 100, 010, 111. So, what will happen when you are visiting 11? So, all right, when you are visiting 11, so what you did? So, you went top, right, 01, and you went down 2 1, and you went right 1 2, and you went left, it is 1 0. And you see, when you go top, right, left, all are zeros, so that you can simply ignore it, so you don't make initiate DFS. But when you go down, you again get a 2 1. 2 1 value is 1, so whenever you are going down, first you mark it as 0, then when you go down, you found 1, so first you mark it as 0, then again you initiate a DFS for you initiate a DFS for 2 1. So it means DFS for 2 1 is being initiated. So 2 1 is initiated. Again, it will go up, down, right, left. So that if you go up, again it becomes 1 1, and right 2 2, and down 3 1, and left 2 0. So if you closely see, you go up. So 1 1 is already marked 0, so that you don't explore further. This is what you don't need to reinitiate DFS already. You already initiated DFS here. Whenever you initiate, you mark it as 0, so that you don't need to reinitiate again. Now when you go right, so definitely when you go right, you will get 2 2. So 2 2 is having 1. So first you mark it as 0. For you will initiate a DFS for 2 2. You will initiate a DFS for 2 2, then we will explore further. So similarly, when you go left, again you have 1. So it means you mark it as 0. You will initiate a DFS for 2 0 also. You will initiate a DFS 3 1 is out of the context. So by the time you went 2 2, so when you go left, right, so when you initiate DFS, it takes all other directions, top, left, down, right. By then all are zeros, so that this will not initiate any other DFS. And similarly, by the time when you are solving 2 0, it's going top, left, right, left, top, down, right, left. By then all are becoming zeros. This will also not initiate any other DFS. So what we are trying to do is, from a given cell, we are trying to mark all other connected cells to 0, so that you consider that complete island as 1. So that's why before initiating DFS only, we are incrementing the counter. Now tell me the time complexity. Tell me the time complexity, buddy. How many times each cell will be revisited? First of all, you scan the complete matrix or grid. So whenever you found one and you initiate a DFS, so that is one time. And whenever you initiate a DFS, in worst case, every cell will be visited 2 times. Correct? Yes or nobody? You see, 1 1 is visited 1 1, 2 1 is visited through 1 1. From 1 1, if you go down, sorry, from 1 1, if you go down, you get 2 1, and from 2 1, you go up, you get 1 1. It means 1 1 is visited twice. Yes or nobody? Ajay? Yeah. So it means it's a matter of 1 plus 2. So it means each cell is visited 3 times, and there are mn cells. So it is going to be 3 into mn. So which is going to be big O of mn. Correct? Correct, buddy. So what is a space complexity? space same grid with space complexity with respect to stack frames we need to decide because it's a DFS code, right? So how it goes. So let's say you have 3 by 3. Assume you have all cells are connected. So all cells are one. All are ones. So it's a single island, right? So definitely you will start from 0 0. Then you will go right. So more importantly, when you call, it has four directions right now, buddy. It has four directions. So more importantly, at a time one direction will work. Okay, so then once that is completed, it will move on to other direction. So let's say I go right. So again I found 0 0 0 1. Okay, so this will also take four directions. uh, so I again go right, so it becomes 0 2 because all are ones now, so all are possible. So first here you mark this 0, then you mark this 0, then you went right, you mark this 0. So then you went, if you go up, this is out. If you go up, right, down, this is out. And if you go down, this is also right, down. Uh, then you go down. So when you come down, you found valid value. So come down. So it becomes, what is it? 1 comma 2. Now again you take left, right, down and top. So top is already marked as 0 so that you don't need to worry about it. So definitely same thing, right? So this is out. Now let's go left. So left, it means you get, definitely you will get 1 comma 1. Again top, left, round, right. So what did you understand? So it's correct. So at any cost, at any cost, so if you closely see, if you start from 0 1, right? 0 1, somehow you get into 0 2, somehow you get into 0 3. Sorry, so if you closely see the time complexity, you start from 0 0, you get into 0 1, you get into 0 2, then you get into 1 1, and you get into 1 1, then 1 1 2, you get into 1 2, then you 1 1, then 1 0, then you get into 2 0, then 2 1, then 2 2. So maybe order may not be correct, but if you closely see, if all are ones, right, all these stack frames will get active, right? Yes or nobody? Yes or nobody? All these stack frames are active, right? So because you initiated from 0 0, so that it is going to be yum cross yan. Okay, so then that space complexity is yum cross yan. So let's write the code. So this is called DFS, depth first search. So you will just go into the depth. That's it. Okay, so let me quickly finish it. So public void DFS. So integer row, integer column. This is character array grid. So now we need to have a base case, right? So the base case is, there is a chance that when you are at 0 0, if you go left, the row becomes, when you go top, the row becomes 0. Or row can reach to the end of the grid, so that when grid dot length, or column may be 0. If you are at 0 0 cell, if you go left, it goes -1. So column less than 0, or column is equal to grid of 0 dot length, so this is column length. Or the more importantly, you don't need to explore further whenever your grid is having 0, right? So if it is equal to 0, then you don't need to explore further, so you just need to return. Done. So we are done. So we are done with the base case. Hope you understood the base case, right, everyone? Please, clear na base case? Okay, so base case is clear. Now let's move on. So what is our job now? First, we mark the current cell as 1, 0. Okay, so it means if you are crossing this base case, means you are marking this current cell to 1. Once you mark this, then what is your job? Take however direction. So First, DFS of column plus one, comma grid. So what do you mean by this? This is right direction now, buddy. Yes or no? Please, bro. This is left direction, right? Because for a valid grid, you need to look for all the directions. DFS of, then down, DFS of top. Done, man. Our code is done. So we are done with the DFS code. Now it's time for us to explore, right? So initially we will maintain counter equal to 0. Then I will start from row 0 and row less than grid dot length, row plus plus. Then for integer column is equal 0, column less than grid of 0 dot length, column plus plus. So whenever you found grid of row column which is equal to 1, it means you found island. So that first increment the counter, then connect all the islands and mark them as 0. So that next visit it won't be possible. So that for this given row, for this given column, just initiate the grid. Finally, you get a counter, and at last you need to return that counter. Bro, code is clear, buddy. Code is clear, Kalyan. So Stack Overflow Y. Let's see. Row grid length column less than 0, column plus 1. What are we doing? Tell me, bro. Why it became Stack Overflow? You should understand. Yeah, so we should mark it as 0, right? If you make it as 1, it's keep on visiting it, visiting it, visiting it. So once you visit it, you mark it as 0. It means it is 1, right? So you mark it as 0, then it will work. So that's it. That's it, buddy. Okay, can you solve other problem, man? So it is uh, but you need to apply a little bit intelligence. You already know the concept of backtracking everything, right? So you can easily solve it. If you closely see, you have lot of islands. You need to return what is the max island. If you closely see, this island is having six ones, right? Yes or nobody? So the expected answer is 6. And if you go, so this island count is 1, this island count is 4, this island count is 5, 4, this island count is 5, but this island count is 6. So you need to return 6. Clear? Can you try this? Or if you don't want me to try it, I can write the code in 5 minutes, as we already discussed it. Do you want me to write? Give it a try, okay? So think about it, and put some time. Earlier, what we did, we just need a count here. So we are just connecting the count. But in the next example, we need to find out how many ones which is been connected. Get that count and take one max variable and return the max. Got it? Already given the hint. Okay. So get the count from the DFS, and you already maintain max local variable and return it. That's it. So that on Monday we can focus on this problem. Okay. It needs a DFS knowledge. That's why we gets into DFS. Okay.